Selection sort. Selection sort is a comparison based sorting technique in which the smallest element gets picked from the unsorted portion of the array and gets placed in the sorted portion. So after each pass in selection sort, one element will be placed at its correct position. In case of bubble sort, we made the same statement. That is, after each pass of bubble sort, we said that one element will be placed at the correct position. Then what is the difference between bubble sort and selection sort? The difference is that in case of bubble sort, which element got placed at its correct position? It was the largest element from the unsorted portion of the array. But in case of selection sort, whichever is the smallest element in the unsorted portion gets placed in the sorted portion. So in case of these sorting techniques, if this is your array, what happens in case of bubble sort after first pass? After the first pass, the largest element of this array gets placed at the last position, which is the right position in case of ascending order sort. What happens in case of selection sort? In selection sort, the smallest element of this array gets placed at its first position. So this is the difference in the way elements are positioned in bubble sort and selection sort. So what we'll do, we'll try to understand how selection sort picks the smallest element, because that is the core of this algorithm. How does it find out which is the smallest element in the array? If this is your input array, what selection sort does is, let us say these are the elements in your array. It will initially start from the first position. So it will consider a variable called minimum, and it will initially guess or assume that whatever is at the first position, or let us say index 0, let us provide indices to all these. Whatever is present at index 0, it will assume that is the minimum element. So in minimum variable, it will store index 0. At this point, it starts going through each element of the array one by one. So this is in linear order. What does it do? It will see whether the element at that position is smaller than whatever is there in minimum index. So in case, let us say your algorithm found that at index 2, whatever element is present is smaller than the first element, that is whatever is present in index 0. So it will update this minimum variable to 2. This means your smallest element till this point is present at index 2. It will continue going through the array, and if it finds that at some index 5, whatever is present at index 5 is even smaller than what is present at index 2, it will update this minimum value to 5. So by the time you go through complete array once, you will know whichever index is holding the smallest element of this array. So let us say 5 is the index that is holding the smallest element which you identified. What will you do? You will swap the element at index 0 with index 5. So these two elements, they get swapped. So after this first pass and this first swap, what happens? Whichever is your smallest element, that gets placed at index 0. In the second pass, you don't consider index 0 because you are already aware that index 0 is sorted. So you will start from index 1 and do the same procedure from index 2. You will find the second smallest element. Then you find third smallest element in the next pass. So this is how selection sort works. What we'll do is, we'll take example so that it gets crystal clear for you. We'll take numbers and take an example and see how it works in each pass and how the elements get sorted. So what I'll do is, I'll take the same elements that we considered while we learned bubble sort. The idea is that when you see the same elements, you will be able to clearly identify how is it different, how the manipulations after each pass are different. So elements are these: 42, 70, 12, 30 and 24. These were the elements. So I want the same elements because I want you to see exactly how these elements get manipulated in case of selection sort and how is it different from bubble sort. So when we go forward learning different sorting techniques, you should be clearly able to identify how exactly does it differ in the manipulation of these elements, because end result you all know all the sorting algorithms are going to give you a sorted list at the end result. The point is how does it do that? After each pass, what difference happens in case of different algorithms? That is the core of logic. So we'll start this algorithm here. You'll have a variable called minimum. In this minimum variable, initially you will consider 42 as the base. Let us provide indices 0, 1, 2, 3 and 4. So you have 5 elements in total. You'll initially consider the minimum element as whatever is at index 0. What will you do then? From index 1, you'll start comparing. Is it smaller than 42? 70 is not smaller than 42. So you'll move to the next. Is 12 smaller than 42? Yes, 12 is smaller than whatever is at index 0. So you will update minimum variable to index 2. You'll go forward. Index 3, whatever is present in index 3, is it smaller than what is present in index 2? It is not. 12 is smaller. So you will go forward. Is 24 smaller than 12? No, it is not. So at the end of the first pass, you know whatever is at index 2 is the smallest element of this array. What will you do next? You will swap index 0 with index 12. So when you swap, what happens? 42 comes here and 12 goes to index 0. So your first pass is done, and at this point you have first element rightly in the correct position. So this is done. So from the second pass, you won't consider this element. This time you will assume your minimum value is at index 1. What happens then? You'll assume minimum value is at index 1, which is 70. You'll go to the next index. You'll compare what is at index 2 with what is at index 1. And you now know that index 2 has a smaller value. So you'll update minimum variable to 2. You'll go to the next element, next index. This time you know 30 is even smaller than 40. So you have to update index 2 to index 3. So this time your minimum index is 3. You'll go forward. What do you understand now? At index 4, you have a value which is even smaller than 30. So you should update this minimum variable to 4. So at this point, you know among the unsorted portion, whichever is the smallest element is present at index 4, which is 24. What do you do now? You swap your index 1 with index 4. So 24 will come here and 70 will go to the fourth index. At this point, your second pass is done and you know first two elements are the smallest two elements in your array and this much is sorted. You'll update your minimum to 42. So you are starting your third pass at index 2. You will compare with whatever is at index 3. You find index 3 to be smaller. So not 42. Here you have to put index number. So 2. So you know index 3 is having a value which is even smaller than index 2. So you should update minimum to 3. You will go to index 4. 70 is not smaller, so you don't have to update. What do you do now? At the end of third pass, you'll swap index 2 with index 3 because index 3 is holding the smaller value. So 42 will come here. 30 will go to index 2. So now you know that first three elements are sorted. You got the three smallest elements in first three positions. This time you will keep minimum value as 3, index 3. Index 3 has value 42. This is your fourth pass. So in your fourth pass, you will compare it with index 4. Index 4 is larger, so you don't have to do anything. And also, you know you've reached the end of the array. So you don't have to swap here because 42 is smaller. And you know at the end of fourth pass, you have first 4 elements sorted. Do you have to do another pass? No, because only one element is remaining. One element is anyway sorted. You don't have to do anything. So this is where you can end selection sort. You cannot end selection sort by checking in between like bubble sort, because in this procedure, you are swapping some random 2 elements, not just adjacent elements. So after one pass, you can't directly say it is completely sorted. So you have to continue selection sort till the point you reach from one end of the array till the other end of the array. So this is the selection sort procedure. And why is this called as selection sort? What is the reason? You can guess by this point because we've already gone through what is the process. Try to guess it out. The reason is you are selecting after each iteration. What are you doing? You are selecting the smallest element from the unsorted portion. You will handpick or select the smallest and place it in the correct position. So because of that selection, it is called selection sort, right? What we'll do now, we'll write the pseudocode for this algorithm and then we'll analyze time and space complexity. So let us write the pseudocode. First, writing pseudocode, what is the logic we are going to write here? Initially, we'll have one loop. What will this loop do? It will go from 0 till n minus 2 because it has to consider that as the base element. Inside this, you want to run one more loop. What is the second loop going to do? It is going to compare all the other elements of the array and then find out whichever is the minimum. After the end of this loop, whichever is the minimum found out by the inner loop, that is to be swapped with whatever is the element of the outer loop. So this is the logic we are going to use. So let's write the pseudocode. Selection sort on an array. Okay, on the array, I am going to do selection sort. One variable that you need will be length of array. So we'll take it as n. N is length of array. Then you can start the loop. So you're starting the loop for I is equal to 0 to till which point you want to loop? Till n minus 2. Why is it n minus 2? Because totally there are n elements, which means indices are from 0 to n minus 1. And the n minus 1th element is the last element. So you only have to loop till here because if you place all these elements at the correct position, last element will be by default at the correct position. So you have to loop from 0 to n minus 2. Then what do you have to do? You want a minimum index. So you will call it min. Minimum, what you will do initially, you will assume this base element as the minimum. So minimum is equal to I. This is what you will assume. Then you should have inner loop. What is the inner loop going to do? It has to, let us say, base is this one. This is your I. Then from I plus 1, it has to go till the end of the array. So for, what should it do? From I plus 1, it should start. So j is equal to I plus 1 to, till which point should it go? It should go till the end of the array. So till n minus 1. N minus 1 is the last index. So from j plus 1, it will go till n minus 1. And what should it do when it's going through each element? It should see whether it is smaller than the element at minimum index. So how do you do that? If, what will you do? AR of j, if this is lesser than AR of minimum, right? If this is lesser than AR of minimum, what should you do? You should update your minimum to j. This is what you have to do. So after the end of this loop, you will have whichever is the minimum element, minimum index at the end of this, at the remaining unsorted positions, whichever is the minimum element, that index you will have stored at minimum. So what should you do now? You should know whether you should swap or not. You should swap only if minimum has changed from I, because otherwise I itself is the minimum. So you should do that check here. If minimum not equal to I. If this is not equal to I, in that case, what should you do? You have to swap. You should swap. Which elements should you swap? You should swap whatever is at I with whatever is at minimum index. So you should swap AR of I with AR of minimum. So this is the swapping you have to do. After this, your complete, whenever this complete loop, outer loop also completes, you know all the elements will be in correct position. So here you can return array, right? Here you can return array. So this is the selection sort algorithm. Let us see what, here you are initializing n, then you have an outer loop. It is considering base element from 0. Each index till n minus 2 will be considered as the base element. For each of that base element, you'll initially consider that base as the minimum. You'll go through all the remaining elements in the array. You will check whether any of those elements is less than the minimum. Then you will update minimum accordingly. At the end of this loop, you will have minimum value for that iteration stored in min variable. You will compare whether it is equal to I or not. If it is not equal to I, you will swap the element at I with element at minimum. You do this for all the n-2 elements. You will have complete array sorted. That is when your selection sort ends. So what is the time complexity here? This loop, it runs for order of n, right? I plus 1 to n minus 1 means order of n. And the outer loop, that also runs order of n times. So n times inside that loop, you have an inner loop which is running n times. So n into n square. So total time complexity is order of n square. Order of n square is the total time complexity of selection sort. What is the space complexity? Space complexity of a selection sort is order of 1 because you are not using any extra space. Whatever you are using are variables which is constant space. You are not using any additional space. So your time complexity is order of n square. Space complexity is order of 1. Is this a stable sorting algorithm? Think about it. Is it stable? Because what are you doing? You are finding the minimum element at some index, and that index you are randomly swapping with whichever element is present at minimum whatever is your starting index. So in this case, if you have two elements with the same value, it is possible that they may get rearranged because of this swapping procedure you are following. Maybe you have two elements of value 30 and one 30 is here, another 30 is at second position. But you started with this 30 as the minimum, the base. You started going through here, you found some element, let us say 10 here. So according to the algorithm, you have to swap this 30 with 10, which means your first 30 will come after the second 30. So your stability is lost there. This is not a stable algorithm, it is unstable. And what about in place? Yes, it is in place because it is not taking any extra space. So it is unstable in place.